Hi students, now we are going to explain the working of a compound microscope. So you can see this is the ray diagram corresponding to a compound microscope. In this microscope there are two lenses. One lens of short focal length is called as objective and the other lens is called as eyepiece. The eyepiece is going to act like a simple microscope. The first lens is called objective because it is focusing towards the object. The second lens is called eyepiece because our eye is going to observe the final image through this second lens. Now the focal length of the first lens, namely objective, is FO. Okay, and the focal length of the eyepiece is FE. And the distance of separation between these two focal lengths, that is denoted as capital L, where L is called tube length. Tube length. So what is meant by tube length? Is the distance of separation between the second focal point of the objective, and the first focal point of the eyepiece. So for any lens, there will be 2 points, namely the focal points. One on the left, that is F1, and the right side is F2. So both the lenses will have 2 focal points. So the second focal point F2 lies on the right side of the objective, and the first focal point of the eyepiece lies on the left of the lens. This distance of separation between the 2 focal points of the lens only is called as the tube length. Okay. Now here you can see that an object AB of height h is placed in front of the objective lens. So its image is formed here. AB dash, A dash, B dash of height h dash is formed on the other side of the first lens, namely objective lens. Now you can see here one ray which is parallel to the principal axis. After refraction through the lens, it gets refracted and passes through the point F2, where F2 only is called as the second focal point. Okay, after which the image is formed here, A dash, B dash, and its height is h dash. This image is inverted image, and this inverted image only is going to act like the object for the second lens. So A dash, B dash is an object for the second lens, which is going to behave like a simple microscope. Now in this picture it is shown that the image is placed inside the focal length, within the focal length, less than F. Therefore, the corresponding image produced by this second lens, like a simple microscope, it is going to act. So the final image will be formed at the least distance of distinct vision. Understand? So D is the distance of distinct vision at which the finally enlarged image, namely A double dash, B double dash of height h double dash is being formed. So it's very simple. In this compound microscope, which you have seen it in the biology lab, there will be a small lens through which you will be observing, that is called the eyepiece, and another lens will be just above the object. Understand? That is a sample which is kept on a base. So now the magnification is done twice. The first magnification is done by the objective lens, and the second magnification is done by the eyepiece. So the total magnification is equal to the product of the two magnifications produced by the objective and the eyepiece. So my dear students, first let us now derive an expression for the magnification produced by the objective. Okay. Now you look at this objective lens. In this picture, you can see the refracted ray passes through the second focal point, F2. Can you see that an angle is made by the refracted ray above and below the principal axis? So these two vertically opposite angles are equal, and I denote this by the symbol beta. Just you watch that angle beta. Okay. Now for this angle above the principal axis, I will find an expression for tangent beta, tan of beta. So tan of beta is equal to opposite side by adjacent side. So this opposite side is also equal to the height of the object, that is equal to h. So opposite to beta is the side h. So I will write this is equal to h divided by adjacent side. You see here horizontal distance. It is also equal to what? The focal length of the objective. So this is h by f naught. Okay. Now the other side, beta below the principal axis. You see what is tangent value of beta? Tan beta is equal to opposite side by adjacent side. So the opposite side is equal to the height of the image. So I can now write tan beta is also equal to h dash divided by this horizontal distance is nearly equal to the tube length. Understand? Nearly equal to the tube length. So h dash by L. So since left hand sides are equal, I am going to equate the right hand sides. So this is now h dash by L is equal to h by f naught. So h divided by f naught. And hence h dash by h. So h dash divided by h is now equal to L by f naught. Therefore, the magnification, okay, therefore, magnification of objective. So magnification of the objective lens is M objective is equal to L divided by FO. This is one of the main equations. Are you understanding, students? First we have derived an expression for the magnification of the objective lens, and that is found to be equal to what? MO is equal to L by FO, where L is called tube length, and that is once again equal to the distance between the second focal point of the objective lens and the first focal point of the eyepiece lens. That is the tube length L. Okay, like this we are going to derive another expression for the magnification produced by the second lens, that is the eyepiece. And now in this picture we have shown that the object A dash B dash for the second lens is nothing but the image produced by the first lens, and also where it is placed within the focal distance. Understand? So the final image is formed here, A double dash B double dash at a distance capital D. That is the least distance of distinct vision. So for this is in the near point focusing. Okay, so this one is what acts as a simple microscope in which focusing now? Near point focusing. So for the near point focusing, directly we can write the magnification of the eyepiece. For the near point focusing, it is equal to 1 plus D divided by FE. So this is another equation number 2. So this is the magnification produced by the simple microscope in the near point focusing. Is it not? Therefore total magnification is given by, this is the total magnification given by M equal to M objective into M eyepiece. So M objective is what? L by F naught. Therefore this is equal to L by FO multiplied by 1 plus D divided by FE. So this is the expression for the net magnification produced by the compound microscope in near point focusing. So this is what near point focusing. Suppose for that is near point focusing is 1 plus d by Fe. For normal focusing means what should have been the expression for ME then? It is just d by Fe, is it not? Hence, in normal focusing, okay, hence, in normal focusing, what is the expression for M? The total magnification is equal to L by Fo into d by Fe. So this is equation number 4. Very easy it is. Derivation is actually very easy. Where the students are going to struggle is only in drawing the diagram. Understand that? So my kind advice to each one of you is, first while drawing the diagram, you draw a very lengthy principal axis. And you draw the first lens very small in size and also is much curved. So the curvature is more. That means the focal length is very short focal length. So the objective should have a short focal length. And then only you can form the image a little closer itself. So that the other lens should be at least twice the size of the image produced by the first lens. So that the picture will be within the boundary of our observation. Understand that? So finally, what is the summary of this? Compound microscope consists of 2 lenses. So the first lens, which is closer to the object, is called the objective. The objective is having a short focal length. The second lens is called as eyepiece because through the eyepiece only we are looking through the eye. Okay. So the image formed by the objective acts as the object for the eyepiece. And the final image is, you can see that the final image is actually, it is a virtual erect image. Understand? But in this picture you can see that it is below the principal axis and the object is also below the principal axis. That is why what is the nature of the image formed by this compound microscope means you can see that it is a virtual and erect image only. Final image is virtual and erect with respect to the first image. Understand? But with respect to the object is, you see, with respect to the object means it will be inverted image only. Understand? So with respect to whom you have to take care. Okay, students. So we are having 2 expressions for the magnification. One for normal focusing, the other one is for near point focusing. So in the near point focusing, the total magnification of the compound microscope is given by M equal to L by Fo into 1 plus d by Fe. And for normal focusing, the net magnification is given by M is equal to L by F naught into d by Fe. I hope you must have understood well. Fine.